Hello folks, welcome to The Age of Asparagus and Phase 3 of making a 3D top-down shooter in Godot. The plan for Phase 3 is to finally make our game playable. We'll spawn enemies in random locations, deal with a player going off the edge of the map, add some weapon variations, a game over screen, add some wave difficulties, and a basic UI and menu. By the end of this video, we'll have our enemies spawning in random locations across our map. Okay, why don't we start by resetting the player's location to the center of the map. I'll just reset the translation in the inspector and set the player's Y value back to 1.5. So, to place enemies on random tiles that do not contain an obstacle means we're going to have to somehow get that information. We know we have some of that information in our nav map script here, in our navigation map. We have the obstacle map right here. And the obstacle map is a two-dimensional array that is going to be true for any coordinate that contains an obstacle. So if we wanted to get a random coordinate and then check if it has an obstacle, maybe we should probably create a variable for random map coordinates. That's going to take our map coordinates array and just shuffle them, similar to how we did in our level generator script. So just like we have here, fill map chords array, why don't we create a new function and we'll call it fill random map chords. And what this will do is it'll just take the map chords array and shuffle them. So how we'll have to do this is we'll create our random map chords array variable, and to start we'll set it equal to a copy of our map chords array. We don't want to set it equal to it because then when we randomize this variable, the map chords array will also get randomized. So we want to actually make a duplicate of this. So that they become disconnected, and then we'll just shuffle them. Soufflé. Okay, so just to make sure we did this properly, let's go to the game script here, and when we load the game, it's going to print the obstacle map, and just sanity check, let's print a few more things. Navmap dot, print the map chords array, and print the navmap random map chords. There we go. So now when we play it, we should see a bunch of things here. We have a problem. So you see those two empty arrays there. We're not actually, let's stop that. We don't actually ever fill the map chords array in our game. So why don't we do that in the ready method here. We'll just call fill map chords array, and then we'll call fill random map chords. So when we're playing our actual game, when this map, the navigation node, is loaded, it will fill up these arrays. Let's just make sure that happens now. Good. Whoops. Good. Let's so make sure one of them should not be randomized and this one appears randomized. Okay, that's good. So if you think about our game here, the spawner class, when our spawner timer times out, it instantiates a new enemy and places it in the scene. What would be nice is if we had a method that would just give us a new coordinate, just the next random coordinate that we could use here. So let's create that in our navigation script. We can just call it get next random map chord. Pull that back. This should be pretty simple. We can just return random map chords, and then we'll just pop the one off the front. So that will remove it from random map chords, and it'll start out here at 10-0, then it'll go 4-4, 8-5, right? It'll pick random ones. Problem is, at some point it could run out. So if it runs out, what we want to do is we'd want to refill it. So let's just make sure that there are coordinates left for us. So we'll add an if statement here. So if not random map chords, because if this is an empty list, it's going to be a falsy value. So if it's not empty is basically what we're saying here, then let's just refill it. And refilling it is just going to set it back to the array, and it'll shuffle it again. And the next shuffle would actually be in a different order, so it'll kind of continue on. Okay, why don't before we return, or, get random map chord. I kind of want to run this and just see it spit out a whole bunch of random coordinates and not break when it runs out. So let's just make sure that's working. And let's do that in our game in the spawner class. So our spawner is going to need a reference somehow to this navigation here, our navigation map class, this node. So let's go up to the top here, and I'm doing this like different ways every time. There's so many ways to do this. So we'll create an onReady var, and we'll call it navmap. And let's set this equal to, you see that dot here that shows up? We can actually use 2 dots. And what 2 dots is going to do is it's going to move back one. Similar to on a Linux terminal, 2 dots will move you back up one directory. Well, this is going to move us back up one node, and then from there we can go back down and get the navigation. So here we can now get the node that is called navigation. And once we have that, now let's see here. Where do we want to do this? I guess for now we can just print it here. So anytime a new enemy is supposed to be appearing, we'll have to position the enemy. Let's do it right after we instantiate it. Right? So we're going to have to give the enemy a random position that is not in an obstacle, of course. So, but just for now, let's make sure we can connect to our nav. So navmap dot, and you can see it connected properly, which is pretty cool, even though we actually only put it, referenced it as a string. It is going back and finding it because it's, you can tell, because it can see the chord method, our chord class. So what do we call it? Get next random map chord. Okay, and we'll see what it prints out. Play that, and it's going to give us a coordinate. It is not giving us anything. Okay, let's get rid of this I'm hit, I hit you. So I'm going to Control-Shift-F and type I'm hit. We don't really need that anymore. There it is. Just comment that out. Control-K and Control-Shift-F. Hit you. There it is. That's the one. Control-K. And if we go back into our spawner script here, oh, I never printed it out. Next random chord. There we go. So we can shoot that guy. There we go. Look, 10, 0, 4, 4. Now it's not using these chords, so now we should see a whole bunch of them pop out. Looks good. I don't actually know if I went through them all. Probably not. But we can check that by making wave 2 100. Oh, that's going to be crazy. Kind of fun to check these things. Here we go. Let's kill the first one. Pew! Next one. Pew! And watch it explode. It's be neat to see how they get pushed around our map. I like how we added that little bit of squishiness to them there. Looking good. Starting to get some lag. But our next random map chord is not crashing. Okay, we better close that before things go crazy. Not sure if you can hear my computer whizzing in the background to try and handle all that. Okay, back to our navigation now. Ooh, I better set that wave back down to 30. I think it was 30. 30 sounds good. So back to our navigation script now. We don't want to get the... So for our spawner, we don't actually want to get any next random chord. We want to get one that doesn't have an obstacle. So let's create a little function here just to make it easy to check if it's an obstacle. So we'll call it isObstacle. And what it'll take is a coordinate. And this is going to be our chord class. type of coordinate. So I'll put a type hint there. And then all it'll do is it'll go look up on our obstacle map to see if that coordinate is an obstacle or not. So we'll just return the obstacle map, since this is going to be true if it is an obstacle and false if it is not. And remember, this is a two-dimensional array. So the first dimension will go look at x, and then the second dimension will go look at the coord's z value. And that should be easy enough. So now, instead of getting the next random coord in our spawner class, we actually want to get, let's call it get random empty coord. Okay. Let's do this with a horrible, you should never do this, so I'm going to do it, infinite while loop. So this is obviously going to assume that there will always be at least one empty coordinate. So we'll come back and fix this when it breaks things and crashes our game. So we're going to create a new coordinate, and it's going to use our get next random coord method. So now we have a coordinate, a random one, and let's just make sure it's not an obstacle. So if not is obstacle, pass it the coordinate, the random coordinate we just got, and if it's not an obstacle, we'll return it. There we go. And if it is an obstacle, it'll just keep going through this loop until it finds one that is not an obstacle. Remember, it is assuming this, so I believe this should always be true the way we set it up. We'll fix that later when it breaks everything. Okay, so let's test this out now. We'll get random empty coord in our spawner. So we'll just change it to use this. Next random empty coordinate. And let's just check if it actually works here. If it's getting an empty coordinate. Okay, so 10, 0. This should be x, and this should be z. So let's check it out if 10, 0, and 8, 5 are empty. 10 would be on the end here. Wait, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes, 10, 0, that one's empty. And the next one was 8, 5. So we're looking at 8, 0, 1, 2, 3, 4, 5. Yep, and that one's empty too. So, I mean, at least visual check it seems to be working. When we start having enemies spawn inside blocks, we'll know it's definitely not working. But for now, that's a good enough check. I'm going to go up here. Let's go to our game and stop printing out all this stuff here. I'll just leave the map width and depth. Okay, so back to our navigation. Why don't we try and spawn them at this random empty coord now? It's not going to work because our coords are not actually XZ positions on the map, remember? But let's just see what happens. And then we can clean it up. We can fix it and give it the right position. So in the spawner class, spawner script, here, what we'll do is we'll go enemy dot translate. So we're going to move the enemy from its location, which is maybe shifted up around on the y-axis. So we're just going to move it along the x and z axis into position. So we'll go translate. We'll have to give it a new vector 3, and that vector 3 is going to be the coordinate. Okay. I guess we need to save that coordinate. So we'll call this location. And then this is going to be a coordinate, remember? Which we could give it a type hint, I guess, if we went. We'd have to go navigation map dot coord. See if that works. Is that going to work? Var? How about var? There we go. We'll know if it worked if when we try and give our location.x. We're not going to move it at all on the y-axis. We don't want to move it up or down. We'll just leave it where it was. And then we'll go location.z. Not sure if that's coming through or not, but we'll find out in a moment. So they're actually all going to show up. If this is 0, 0, of course, because our coordinate system, our chords go 0, 1, 2, but when we translate those into 3D space, this is 0, 0, right? So everything's going to show up over here. And in fact, our tiles are actually too wide. So we're going to have to take that into account too. I wonder if I can kill this and just see what happens when lots of them come. Can I? Yeah, I got them. Okay, there we go. Yeah, look, see, they're all appearing in this quadrant here. Not bad, not bad. Okay, so we don't actually want to get a location as a coordinate, right? We don't want to get a random empty chord. We want to actually get a vector 3. So back in our navigation again, we're going to add one more method here. You kind of see they all build on each other and just use each other. And that is, we'll say get random empty vector 3. But the first thing we're going to do here is convert chord to vector 3. Okay, how are we going to do that? That sounds like a useful method we could use other times, so I'm going to actually make that its own method. We'll call it func chord to vector 3. And you'll pass it a coordinate and it will return a vector 3 in our world space as opposed to our kind of like coordinate map space. So to do this, we're going to need to know the cell size, and our cell size is 2. Each of those blocks are 2 units, so we'll create a constant up at the top here called it cell size and set that equal to 2. Oh, yeah. Well, we're going to type here anyway. Okay, so now that we have the cell size, we need to figure out what is our actual x variable going to be equal. Well, naively, we could just go cell size times the x value of our coordinate, and z is going to be cell size times the z value of our coordinate. And then from there we could return a new vector 3, which would be x0, because remember we're not shifting on the y-axis up and down, z. So to get a random vector 3 now, this is going to have problems. We're going to have to tweak this, but for now we're just multiplying the coordinate by 2, so it maps onto our world space a little better. And then in here, what we'll do is we'll return chord to vector 3, and that chord will be, that will pass it, will be get random empty coordinate. So we're going to get a random empty coordinate, we're going to convert it to a vector 3, and then we'll return it. So let's use this method. See how that works. In our spawner script, we'll switch out. Instead of getting a coordinate, we're going to get a vector 3. That's a method. And let's see how that works. These are once again going to spawn in. Oh, whoa, whoa, crash. Oh, yeah. Hey, there's our safe typing working for us. We did say that it was going to be a chord, which it is not anymore. It's a vector 3. Ooh, okay. So now what we should see is, because we're multiplying it by 2 now, they should show up in kind of like on our map, but it's going to be something like this, right? They're all going to show up in this box because this is 0, 0, this will be 0, 1, right? Because we're going to need to, although we scaled it properly by multiplying it by the cell size, we now need to shift it that way, right, by half the width, and we'll have to shift it that way by half the depth on the Z, right? Okay, but why don't we just see when we have 30 appear that they actually all appear in these boxes. So we'll kill this guy if I can. Good. Yeah, there they are. Yep. So they're probably in empty spots if they were shifted over and we did this right. So let's go back to our navigation again. And we're going to have to do a shift here. We're going to have to subtract half the width. So the width is going to be the map width times the cell size. And then we want to shift by half of that, right? So we'll just divide that by 2. And we can do the same thing here with the map depth. And run that. That's interesting. So they're not appearing in the right spot. It's pretty close. But we have a little problem. If you notice, they all seem to be off by like half a cell. And I'll just run that again just so you can see here. Even with these first two where they appear, they're appearing like on the corners here, instead of in the center. And that's because when we, remember this is 11 long and this is starting at 0. So if this is 1 here and we divide it by 2, we're going to fall halfway here. And that's because like our coordinates are 0 indexed, right? Like this one is actually 0, 0. So easy way to think of about that is if this point here is 0, 0, and we subtract half the width, well, the map width is 11. So what we're doing is we're subtracting 11 divided by 2, which is 5.5, right? So we're going 1, 2, 3, 4, 5.5, and that's why we're ending up on the edges. So what we actually want to do is we don't want to consider it as like a 0 indexed width where this is 0, 1, 2. We want to make this 1, 2, 3, 4, 5 up to 11 here. So what we'll actually do is instead of using the map width, we'll use the map width minus 1 and the map depth minus 1. And then what would happen is we would be subtracting 5 instead of 5.5, because 10 divided by 2 is 5. All right, so we can fix that by right here, instead of subtracting the map width scaled by the cell size, we'll do 1 less than that. Okay, and now they should be showing up in good spots. And this will be our real test right now. All right! Looks like it's working. Good work, everybody. Good show. Good job.